Okay, this video is a continuation of homework 7, 4.5, U substitution. I'm looking at what was my problem 8, which was the integration of r squared times r cubed plus 6 to the 5th power dr. Alright, looking at this problem, alright, it doesn't match any of the rules that I have. Remember, the rules are on page 250 in your textbook, all the rules you need to know at the completion of this class. For integration, we only have a few basic rules, and this problem does not match them. Okay, so what I need to do is use something called U substitution. I'm going to find something that U can represent. Usually, what it's representing is inside of something. So I'm going to try this right here. I'm going to let U represent r cubed plus 6. Now, I'm going to find the derivative of this to get 3r squared dr. Okay, the reason I'm taking the derivative is because when I rewrite this in terms of U, this also, the dr, also has to be in terms of U. So when I take the derivative of U, I get du, giving me something where I can solve to find something to plug in for dr. Okay, now looking at, to check to make sure I've chosen the correct U, I'm going to see, I don't care about, remember, we don't care about the number part because we're going to pull that out anyway. I'm looking to see r squared, is it somewhere in my problem? And yes, it is r squared, so I'm good. My, this is going to cancel out with my derivative, so I don't have to worry about that. In some cases, it will not, okay? But we are not going to see any problems like that in this homework, so you will probably encounter those in Cal 2. So there is additional work you can do to get rid of this, should it not cancel out. But this is also a way to make sure you've chosen the correct U. If you take the derivative and it doesn't show up, okay, so for our problems, you've probably chosen the wrong thing. Alright, so now let's come in here and substitute r squared in place of this. I'm going to put u to the 5th. For dr, I'm going to solve this for dr, dividing both sides by 3r squared. Alright, so in place of dr, I'm going to put du over 3r squared. Alright, so now in place of dr, we put du over 3r squared. Now, this r squared and this r squared will cancel each other out. This 3, notice it's in the denominator, so it's not actually a 3, it's a 1/3. So I'm going to write 1/3 integration. That is now gone. I have u to the 5th power du. Now I have a single base that I can integrate, so that will be 1/3. When I integrate it, no longer need the integration sign. That'll be u to the 6th over 6 plus c. Remember to put the plus c if it's not a definite integral. Alright, we're going to simplify. That'll be 1/3 times 1/6 times u to the 6th plus c will be 1/18 u to the 6th plus c. Remember, our problem started in terms of r, not u. So we have to go back and in place of that u, put what it was substituting for, which would be r cubed plus 6. Don't forget your exponent there, plus c. Okay, so if you're putting it in to MyLab and it's counting it wrong, all right, make sure that you have not forgotten to what u was representing to put it back in. So whatever variable you start with, that's what variable you should end with. All right, the last problem I want to look at in this video is problem number 9. Problem number 10 is going to work similarly to it. So you will have seen everything in problem 10 in previous problems. Okay, so I'm only going to work number 9. We're going to use the substitution rule. This is a definite integral, so the first thing we need to do is integrate. We're going to have to use U substitution. Once we get it integrated, then we will go in and plug in our lower and upper bounds. Okay? So here's the problem that I had in my homework. Your problem number 9 should look similar to it. I'm going to take this and write it on my paper so you can see me work it out. Okay, so problem number 9 is the integration of x cubed plus 9 to the 4th power times 3x squared dx. Alright, when I look at the problem, I don't have a rule that handles products. I also don't have a rule that handles binomials raised to powers. Okay, unless they are like the ones from the previous homework as I mentioned before. Okay, so u is going to represent x cubed plus 9. Now, we've decided on u. It's inside these parentheses, x cubed plus 9 to the 4th power. That's our u. We're going to do du. So that'll be the derivative here. That'll be 3x squared dx. Alright, so now what we have, we're letting u represent that. So that'll be u to the 4th. We have 3x squared. We haven't done anything with that. And now we have dx. So we're going to solve this right here for dx by dividing both sides by 3x squared. So in place of this dx, I'm going to put du over 3x squared. Alright, now this 3x squared and this 3x squared will cancel out. And I'll have u to the 4th power du. This is something I can integrate. So when I integrate it, I'll have u to the 5th. So add 1, then divide by it, plus c. And don't forget, our problem started in terms of x, not in terms of u, so we're going to come back and in place of u put what it was substituting for, which was x cubed plus 9. Okay, and so we don't need the c. Let me take that off. We don't need the c because this actually did have upper and lower bounds of 0 and 1. I didn't write those down earlier. So this is going to look like this. So once you integrate it, then you no longer have the integration symbol, and so that's why we moved the lower and upper bounds to this side. This lets me know that this has been integrated and that these are my bounds. This symbol right here still is saying that it needs to be integrated. So once you actually do the integration, this sign is no longer needed, and you would move to this. This lets me know this has already been integrated. Here are my upper and lower bounds. Okay, so I'm going to add those in there. No c necessary with definite integrals. Alright, so what I'm going to do is come in here, and I'm going to start by substituting 1 in place of the x's. So I'll have 1 cubed plus 9, and all of that is raised to the 5th power over 5. Then I'm going to subtract from that 0 raised to the 3rd power plus 9, and all of that to the 5th power divided by 5. Then I can use my calculator, and this will be 1 plus 9 is 10 to the 5th power over 5, and this will be 0 plus 9 will be 9 to the 5th power over 5. Don't forget to subtract. When I put this in, this comes out to be 10 to the 5th power is 1 and 5 zeros. 9 to the 5th power is 59049 over 5. And when I subtract that, I'll have 40,951 over 5. There's no need to put the comma in inside of my math lab. Make sure that you read how it wants you to put the answer in. It doesn't really say. So it may say in the actual homework, but as with the others, probably not a decimal. Make sure you put it in as a simplified fraction. This one wants it as a simplified fraction, so I'm sure this one will also want the same thing. So here would be my answer. Remember, if I'm putting numbers in, I'm probably going to be getting numbers out.